Hello everybody, today I'm back with another video, and today I'm going to be covering some algebra problems. Specifically, I'm going to be covering some trigonometry problems. And so these are mostly in pre-calculus, but they may be tested in your algebra class as well. So it's good to be aware that anything like this could show up. So I'm going to start with the first problem here. This ink was well a second ago. So cosine squared x is equal to, if I remember correctly, cosine x plus 2. And I actually saw this problem. One of my peers actually showed me this problem and said, like, hey, could you help me with this? And so I figured, like, okay, why not give it a shot? And it seemed like a good problem to show you guys. So what you would do with this, and this seems pretty complicated. One might think of the trigonometry identity. You might replace this with 1 minus sine squared x. That's actually what I did when I was first working through this problem. But then I figured there's actually a much easier way to deal with this. So if you notice, any trigonometric function here is cosine. You have a cosine here, and then there's no trigonometric function there. So one thing you can do, actually, is move everything to one side. Let me see my marker. Okay, I'm going to get a different marker. My marker is not functioning the way I would like it. Is this any better? Okay, that looks much better. Yes, that is much better. So we're going to move everything to one side. And I could move the cosine squared x to this side, but I'm going to move these two terms to this side, because that's how I solved it initially. And so we have something like this. Keep in mind they're going to be minus because I moved them to the other side. So cosine squared x minus cosine x minus 2 is equal to 0. Now, something might pop up at you, or something might not. And it's completely fair to assume that something might not. Now, this isn't a trigonometric identity, just to give you a little hint. What it is, let's say, okay, so what I'm going to do now is I'm going to let... Oh, goodness, the quality just went down horribly. Okay, there we are. So we're going to let y equal... Sorry about that. Y is equal to cosine of x. So we're going to declare this other new variable, y, and it's going to be equal to cosine of x, okay? Keep in mind, y is nowhere here. So let's replace y with cosine x. Let's do it down here. So we get y squared. We get y minus y, and then minus 2 equals 0. Now you might see it a bit more clearly. This is like a quadratic function. Now let's factor it. So I like to use the box method. Some of you might find another method better. I think there's like at least two pretty well-known methods that are taught. But this is the one I used in Algebra 1 first, and this is the one that I remember the best, so that's why I use this typically. You can also use like the quadratic formula to solve for it, but yeah, I think it's easier to do it this way. So we got minus 2y squared minus y. We get 2y minus 2y, and y over here. So we get minus 2y. And y, we get minus 2, y, and 1. So these are our factors. So we get y minus 2 times y plus 1 is equal to 0. So that is our quadratic so far. And I forgot to mention one other thing at the beginning of the problem, that the range, it has a set range, and we have 0x to 2 pi, and it is equal to 2 pi. And so that is our range, and this will matter at the end of the problem. So here we have this, and what will happen is we will replace these. Actually, not yet. We are going to have to solve for y. We need to solve for x, keep in mind, but y is equal to cosine of x. So isolating y will give us x eventually. So if we solve, y minus 2, is equal to 0. So this is supposed to be minus sign. Y plus 1 is also equal to 0. Now let's isolate y as I said we were going to do. So we got y is equal to 2, y is equal to minus 1. So y is equal to 2. That means cosine of x is equal to 2. Cosine of x is equal to minus 1. Now you could do the arc cosine function, or if you know what the inverse cosine function looks like, you can also solve it that way. If you know what it looks like, you'll know that cosine of, arc cosine or cosine inverse of 2 is actually undefined. It's out of the range. So that means this is out of range. So that means this is undefined. This doesn't give you an answer. But this one will. Cosine of x, you actually don't even need arc cosine. You don't even need arc cosine on the calculator. You can just solve it your own way. If you know the unit circle, of course. And you can actually replace this with pi, and you'll see that cosine of pi is actually negative 1. Again, you need to know the unit circle. If you know the unit circle, it's pretty easy, and you'll get pi for this. So, what does this mean? That means that the answer to this is pi, and if you actually test it out, it will work. If we put in cosine of pi right here, this will be negative 1 plus 2, that's just 1 on this side. Cosine of pi here, and then square that, that's 1. 1 is equal to 1, so obviously pi is going to work. Now I said that we were going to come back to this range part here. And now I'm going to come back to it. So you'll notice that pi does fit into the range of 0 to 2 pi. It's smack dab in the middle. But the issue here is you may also notice that 3 pi, if I were to substitute 3 pi into this, it would work. But since it doesn't fall in the range, it's not an answer. Sometimes your teacher, or wherever you're taking this test, might ask you to solve for all values of x. What would you do in that situation? You would do, so you could take pi plus n, and it would be a sort of function that would sort of encompass all pi, 3 pi, 5 pi, it's not really showing out here, and you would go on, and negative pi, and you also have negative 3 pi, and all of that, you would have, it would encompass all of this, and you can try to find the function for that. It's not really a function, it's more of an expression, but yeah, if you find it, then please do leave that in the comments down below. Yeah, I'll let you guys do that, and I gave you a little hint. So, anyway, we are going to go to the next one, because there are actually 2. And this one I feel like is a bit harder to catch. This one, I feel like if you just know what to look for, it's easy to catch. Actually, the second one I feel like is slightly easier. So we have root 3 2x is equal to 2. Oh, sorry. No. Oh, I remember now. Yeah, I messed up the numbers. The problem was, I'm memorizing this. I'm getting this off the top of my head, not a problem worksheet or anything. Erase that. Okay. So, we have 2 sine of 2x is equal to root 3. Something might pop out at you, but then you might fall a bit confused. You might think that, whoa, okay, let's get that 2 that's out in the front over here, let's get it over to this side, since we need to isolate x. We got root 3 over 2. You may notice that sine of theta can mean any angle, there's an angle that makes it equal to root 3 over 2. You might be thinking about it, and you might reach that, whoa, pi over 3, and 2 pi over 3. And by the way, that same range I was talking about, I forgot to mention this range. This range right here is also going to work out for this one as well. It was in the problem. I forgot to mention it. Again, I'm getting this off the top of my head. So, here we are, and sine of 2x is going to be equal to that. And so what value goes into x? So one thing if you did notice the values for theta on the for root 3 over 2. So what does sine of theta of root 3 over 2 mean? Like what is theta in this case? Theta can mean pi over 3, and that might be the first answer that jumps out at you. You may also know pi it might equal 2 pi over 3. You can try solving it in your calculator or using the unit circle, which I think is the preferable method. But both of these will equal to root 3 over 2. So does that mean they're both the answers? Well, yes, actually, because it does fall in this range of 0 and 2 pi. But this is for sine theta. We have 2x. So what does this mean? What do we do? Now, some of you may have noticed it already. We take 2x and we make it equal to our values of theta, whatever we got for theta here. So 2x is equal to pi over 3. We get 2x is equal to 2 pi over 3. So we can solve it for both of these. X is equal to pi over 6. 2x is equal to pi over 3. X is equal to pi over 3. All I did was just divide 2 in both cases. I just did it implicitly without telling you guys. Sorry about that. But we got pi over 6, pi over 3, and if you put them back into the original function, that's what you will get, and it will be the right answer. So, a similar thing will happen where I mentioned the last question. You'll get a expression that'll represent a bunch of values for this. You'll get actually 2 expressions, I believe, to obtain the answers for this, assuming the range was all real numbers. For this case, we got a set range, 0 to 2 pi. So only these answers would apply. But if we were to go with, if I remember correctly, 13 pi over 6. 13 pi over 6 is actually outside this range. So it would not apply if this range was here, like it is. But if it wasn't here, if we were to imagine that this range wasn't here, we would actually put it in and we'd get the right value. So that's one thing to keep in mind.